Welcome to our discussion on collecting data. The objective here is really just to be able to distinguish between the various sampling techniques so you know which one is most appropriate for the data you're trying to collect. And that's really the crux of all statistics, right? Anything you're trying to figure out starts with collecting data. And if you collect the data improperly, it's, like they say, it's building a house on sand. It all falls apart if you don't have a strong foundation. So let's start off with some basic vocabulary, right? The population is the group of interest that we're trying to study. And it could be, a population of people, a population of objects, right? A population of animals, whatever that particular set of things are that you want to learn something about. And then, of course, the data is the information that you're going to collect to enable you to, make some guesses and hypotheses about what's going on in that population of objects. A census is what happens when you're able to collect data from every member of that population. So you may have heard, the U.S. Census is done every 10 years where we try and collect data on all of the citizens of the United States. Of course, it's impossible to do that. People are always dying and being born and moving and all that kind of stuff, and there's just people that refuse to return the census. But it's as close as we can get. A parameter is any kind of measurement, right? Any kind of numerical description that is measured on an entire population. And remember, a population can be small things, like maybe you're only concerned about the people in your city. And if you were only concerned about, let's say, the average household income for households in your city, you could very easily get that data depending on how big your city was, right? And then if you were able to get the data for every household in your city and have the average household income from that data, that would be a parameter because to you, your city is the population. But then let's say you want to expand that and use that data to then make an educated guess on what the average household income is for your entire state. Well, now you only have a sample. And that average that you have, that mean, is now considered a statistic instead of a parameter. So whenever you have a sample, it's just a subset of the thing you're trying to study. And when you do measures on your sample, you get a statistic. And it's kind of easy to remember. Sample, statistic, both S's. Population, parameter, both P's. So let's look at them side by side, right? Your population is the entire thing you're looking at. The sample is just a subset of that, right? A part of that group. The population is the group that you're really concerned about knowing something about that. And then the sample is the group that you actually do know something about, right? Because it's the actual data you can gather. And then from that data, you can infer, right? Make an educated guess about what's happening in the population. So the numerical descriptions of the population are parameters. Those from the sample are statistics. Parameters are almost always unknown. It's very hard to get a parameter. And like I said, it all depends on what your population is, right? If your population of interest is small, then of course you can have a parameter. But most studies are concerned with being able to generalize to a large population of things. And so normally we don't have parameters. We only have statistics. And statistics are always known because you can always take a sample. Parameters are fixed, right? Because once you have a population of things, that average isn't going to change. That thing is fixed as this is my set of stuff, and it's not going to change. Statistics, however, can change based on the type of sample you take. And in fact, if you have a population of things and you sample from them over and over again, you'll get different results each time. So let's look at a simple example where we can identify the parts of a survey. So 2 shortened survey reports are given. In each report, identify the following: the population, the sample, the results, and whether the results represent a sample statistic or a population parameter. So we've got a headline about the rising obesity among young people led a school board to survey local high school students. Out of 231 students surveyed, 58% reported eating a high-fat snack at least 4 times a day. So what's our population of interest? Well, it sounds like they're, interested in knowing what's happening with all local high school students, not just the ones, at that local high school, right? All local high schools, not just a specific school. So therefore, we have a sample of 231 students. The results, of course, 58%, and that result is a statistic because it's just from our sample that we took from just one school. Wouldn't be a good sample, by the way, if we were trying to figure out things for all schools, right? You wouldn't want to take your entire sample from one school. You'd want to spread it out amongst all the other schools. How about a nonprofit organization interviewed 618 adult shoppers at malls across Louisiana about their views on obesity and use? The resulting report stated that an estimated 48% of Louisiana adults are in favor of government regulation of high-fat fast food options. So you can see that their report, right, their stated result is that 48% of Louisiana adults. So that tells you that their population of interest is all adults in Louisiana, right? Louisiana adults. But they obviously didn't ask every adult in Louisiana, so they have a sample of 618. Now, the 48%, that is really a sample statistic because they got that from their sample. Here they're saying it's a population parameter, but what they're not telling you is they used their sample to estimate what's happening in the population. So it's not really a true population parameter. It's an estimate of what the population parameter might be. And in fact, it's a terrible estimate, as we'll see in other courses, that you can't estimate with a single point. You can't just say 48%. You can say, well, the population parameter is somewhere between 40 and 50, right, depending on how big your confidence interval ends up being. But again, that's a conversation for another day. A representative sample is one that has the same characteristics as the population, and therefore it doesn't favor one group of the population over another. So for instance, if you wanted to figure out how your state is going to vote on an initiative, and you know that your state is made up of, let's say, 30% Democrats, 50% Republicans, and 20% undecided. Well, if you go out and take a random sample, you want to make sure that you get a representative random sample. So in your random sample, you want to make sure that 50% of your sample are Republicans, 30% of your sample are Democrats, and 20% of your sample are undecided, so that it kind of has the same distribution. It's a representative sample of the population that you're studying. So a random sample is just one in which every single member of the population that you're studying has an equal chance of being selected. So in the previous example of voters, you're basically picking voters at random. Like maybe you're just, you're taking the list of all registered voters and you're randomly picking voter numbers and then sampling those people. Then, therefore, everybody has the same chance of being chosen because you're just randomly picking from that list. Stratified sample is one in which members of your population are divided into two or more subgroups called strata, and those strata are, you basically have a characteristic, and you're going to group people by that characteristic. So a simple one would be like gender, right? You could put males in one strata and females in another strata. Voting, right? You could put Republicans in one, Democrats in the other, independents in a third, maybe undecided in a fourth, that kind of thing. And then once you have them in their strata, you take a random sample from each of the strata. And this is how you could get a representative sample for the voting example, because then you would go to the Republican strata and you would randomly sample, let's say, 50 people. Then you'd go to the Democrats, you'd randomly sample 30 people. Then you go to the independent strata and you'd randomly sample 20 people. And then it would match the distribution in your state because you would have 50, 30, 20, right? So out of 100, you have 50%, So it would match the percentages that you have. So that's a stratified sample is one way of guaranteeing a more representative sample when you are concerned with the distribution of a certain characteristic or trait, like gender, age, voting preference, things like that. Okay, can you think of some other ways to divide cars into strata that might represent a broader scope of vehicles on the market? Well, take a second, think about it. There's obviously a lot of answers, but some would be size of engine, manufacturer, the make, safety rating, number of doors, colors. There's all sorts of ways you could go, right? Now, a cluster sample is similar to strata, but quite different. It's chosen by dividing the population into groups called clusters. So, before we divided them into strata, but now we're dividing them into clusters. And the clusters are each similar to the entire population, right? So before the strata, you had a characteristic, right? And you put all the Democrats in one, all the Republicans in another. Now you would put them in groups that would have that same similar distribution amongst each of the groups, right? So each group of things would be roughly 50% Republican, 30% Democrat, 20% undecided, right? That kind of thing. And normally the clusters are geographical, is one of the easiest way to cluster things. And then once you have your clusters, what you do is you take every member of some of the clusters. You randomly choose a certain number of clusters and then sample everything from those clusters. So here's a good way to visualize the differences between the two. So in stratified on the left, you can see that each group is homogeneous, right? It's the same color based on the characteristic, right? So you could think of this as maybe 6 different voting preferences. So you got all of the people who vote this way in this strata and so on and so forth. Over here, however, you can see that each group, right, each cluster is heterogeneous. It has all the colors in it. So it has all the voters. And it has the same distribution in both of them, right? There's the same number of pink and red and da-da-da in each of these. Although it looks like it's missing a yellow, but you get the idea. Stratified is then you go to each of your strata and you randomly sample from among them. And you'll notice that the samples don't have to be the same size because, again, if you want to be representative, you would take different size samples from each strata so that it was more representative of the distribution of those characteristics in the population. And then in cluster sampling, you would just randomly choose a certain number of clusters and then take everything from each cluster. And that's the difference between those two. All right, take a second and see if you can do this skill check. And there's your answer, right? Because cluster sampling is an all from one group method. Comparing miles per gallon from cars in only certain price ranges would not produce a representative sample. A systematic sample is one chosen by selecting every nth member of the population. So this normally happens when you have a list of things that are kind of sorted numerically. Like on a voter registration, you could sort them alphabetically even. And then you could decide, okay, if I have 10,000 voters and I want 10% of my sample, then I want to sample 1,000 people. So I need every 10th person. So you would randomly choose a number between 1 and 10. You get 3, so you would go to the third person on the list. And then you would go every 10. So then you go 3rd, 13, 23rd, 33rd, and so on and so forth. And that would give you a systematic random sample. Okay? If you were identifying every 8th car accessing the interstate on a particular entrance ramp during rush hour traffic, is this an example of a systematic sampling for your fuel study? And can you identify any biases? Take a second and think about that. Well, it is definitely systematic because you're taking every 8th. But depending on where the entrance ramp is, right, you could get a completely skewed sample because, people live in clusters, right? So you could get all business people in one entrance. You could get maybe the expensive neighborhood where people have higher end cars, that might have better gas mileage, those kinds of things. A convenient sample is just what it says. It's a sample that you take that's convenient, right? You don't have the time and resources to go and get a really good representative sample, so you just take what's convenient. You just look around you and sample the things that are around you. So take a look at this skill check and see if you can answer that. And you can see that there are problems with that kind of sampling technique. All right, let's look at a bunch of examples of sampling technique to see if we can identify what they are. So to conduct a survey on collegiate social life, you knock on every 5th dorm room door on campus. What do you think that is? Well, if it's every 5th, it's got to be systematic. All right. Student ID numbers are randomly selected from a computer printout for free tickets to the championship game. So we've got a whole list of numbers and we're just going to randomly pick a bunch. What does that sound like? How about random sampling? Fourth grade reading levels across the country were analyzed by the school board by randomly selecting 25 fourth graders from each school. So we're picking 25 from each school. What do you think, cluster or stratified, right? Did we take all fourth graders from each school or just 25 from each school, right? If it was cluster, you would take everything from a few schools. If you take some from all schools, it's stratified. In order to determine what ice cream flavors would sell best, a grocery store polls shoppers that are in the frozen foods section. What do you think that is? Well, that sounds pretty convenient to me. And lastly, to determine the average number of cars per household, each household in 4 of the 20 local counties were sent a survey regarding car ownership. So you see how we're picking a certain number out of the total, right? So only 4 of the total 20 local counties were chosen, and then we surveyed everything inside those 4, therefore cluster sampling. All right, good job. That's all I've got for you.